here's our last video for this section. We're going to be using our properties of logarithms now to go backwards. So in our last video, we were expanding our logarithms. Now we have some that are already expanded, and we're going to be writing them as single logarithms. So we do the process backwards. The first thing we're going to do is use the power property to take our exponents and put them as powers. So 2 log x is going to turn into log x squared. And then the 3 would be negative log x minus 1 to the third. Notice how I just took the 3 and not the negative. Okay, so I've used the power property to put the powers back on. Now notice our logs have the same base, that's important. So now we're going to write this whole thing as a single logarithm with the same base of 10, and we don't need to write the 10. So the first one, x squared, is going to go on the top of a fraction. And then the second part, because it's subtracting, is the bottom of a fraction. So x minus 1 cubed. So there we've written our logarithm as a single logarithm, and we are finished with that particular example. Same thing here. Let's go ahead and use our power property. So that gives us natural log u to the 4th power. I'm going to reorder these just because the plus means it's going to go on the top, and the minus means it'll go on the bottom. This one's going to have some interesting simplifying to do. So let's go ahead. Adding means multiply. Let's do natural log of u to the 4th. That doesn't look like a 4, it looks like a 9. U to the 4th times 1 over u. I'm actually just going to leave this part separate for now, just so I can focus on simplifying this really fast. So u to the 4th times 1 over u, isn't that u to the 4th divided by u? So that changes that to natural log of u to the 3rd. So then when we subtract natural log 5u, that means we are dividing. So u to the 3rd divided by 5u. But look, now we're dividing by another u. U cubed divided by u is going to be u squared. So our final answer will actually be u squared over 5. Putting parentheses around it so I know that that is all part of the argument of our logarithm. Now we're going to use these properties to solve some logarithm equations. So the first thing we're going to do is write as a single logarithm. So you can see we have 2 logarithms with the same base on one side. We're going to go ahead and write that as a single logarithm. It has subtraction, so that's going to be division. So we have x over 2. Okay. Now that we have a single logarithm, it's easy to write this in exponential form. So we're going to rewrite our problem in exponential form. So this would be log base 10. So 10 to the 1st power is this answer here. So let's rewrite that in exponential form. 10 to the 1st power, the logarithm is the exponent, equals the argument of the logarithm. Well, that's pretty easy. 10 equals x over 2. All we have to do is cross multiply, and we end up figuring out that x must equal 20. Now here's a step we didn't have to do when we were solving exponential equations. You always have to check your answer. And the reason you have to check your answer is because it might be extraneous. We have to figure out if it's actually going to work in the problem. Because we can't take the log of a negative or 0. Okay, so let's go ahead and plug our 20 back in. So if we have log of 20 minus log of 2, that should equal 1. We could go ahead and use our properties to put that together. So log of 20 divided by log of 2 would be, minus would be 20 divided by 2. And that would be log base 10 of 10, and log base 10 of 10 does equal 1. So when you're checking your answer, you could actually check the whole thing and make sure it works. Or you could just look at this part right here and see that you're not taking the log of 0 or a negative, and that's enough usually to know that it's going to work. Okay, our last equation here, we are going to go ahead and put it together as a single logarithm. So we have log base 2 of x times x minus 1. That whole thing is part of our argument. Now we're going to change to exponential form. So that would be our base 2 to the first power equals x times x minus 1. I'm going to go ahead and distribute. So I'm kind of doing 2 steps in one. X squared minus x. Now we can see that this is going to be a quadratic. We kind of skipped our chapter on solving polynomials and quadratics and things, but you should have learned about these extensively in secondary 2 and in secondary 3. So let's see if you can remember solving quadratics. I'm going to go ahead and move everything to one side. So what I'm doing here is I'm solving the quadratic, and I'm going to use the zero product property. So to do that, I have to factor. And then I set each factor equal to 0 to use that zero product property. We saw that at the beginning of Hidden Figures when she was like a little kid in a junior high class at the board teaching or showing how to solve the problem using the zero product property. I don't know if you remember that. The class is all shocked at how good she is at math. Good old Catherine Jackson. Okay, so x minus 2 and x plus 1 would be our factors. I'm pretty good at just doing these in my head. Let me show you what I did. So x squared is x times x, and then negative 2 times positive 1 is negative 2 in the middle. Now, if we were to FOIL this back out, our inside-outside terms add up to this middle term. So we have negative 2x plus 1x gives us our negative x in the middle. Okay, now our zero product property is x minus 2 equals 0, so x equals 2. And then x plus 1 equals 0, so x equals negative 1. Last step, we have to check our work. If we do x equals 2, I think we're okay because log base 2 of 2 plus log base 2 of 2 minus 1 doesn't give us any negatives or zeros in our logarithms. So that one's good. But our other one, if we do log base 2 of negative 1 plus log base 2 of negative 1 minus 1, that means we're doing negative logarithms on both of them, and not even one of them would have been possible. This could have been positive and this negative, and it still isn't possible. So this one is what we call an extraneous solution. You don't even need to list it as a solution. You just need to make sure you check for it so that you don't list it as a solution. So our only answer to this problem is x